Hello, this is All2. Today I'll be introducing the electric motorcycle transmission I mentioned in the previous video. This video demonstrates the operation of a 3-speed transmission using a 3D printed prototype. At this stage, the components are partially assembled. After inserting the bearings, the gears and shaft were assembled. This planetary gear is used in the channel mechanism for shifting. 3 pairs of small planetary gears have been individually assembled. This is the camshaft, which has 4 pole supports. The camshaft and the pole supports can be angularly offset from each other through this spring. When misalignment occurs, it immediately self-aligns. When misalignment occurs, the pole supports retract, and when alignment is achieved, they expand. The camshaft is inserted into the inner diameter of the main shaft. The camshaft rotates inside the main shaft, following the required angular position. This small component is a pole used to engage or disengage the gear. The pole can be inserted into the outer surface of the shaft like this. One of the 3 idling gears is engaged with the shaft to transmit power. Since the camshaft becomes hidden when fully inserted, this view makes it easier to understand. The pole cannot protrude due to the internal gear teeth. The pole engages when aligned with the internal gear teeth. When the pole protrudes, the support angle must be aligned. When the support aligns with the pole, it locks the gear. If the camshaft rotates like this, it won't support the pole. Then the gear rotates freely. There are times when the pole cannot protrude like this. However, the camshaft rotates freely thanks to the support linkage. And this spring ensures immediate self-alignment. It rotates freely like this. This also applies when the pole and gear are meshed. When engaged like this, a strong load is transmitted to the pole. As a result, the pole is forced inward toward the shaft. Then a strong load is also applied to the support. However, thanks to the linkage, the camshaft can rotate easily. I am applying force to the gear with my finger. However, the camshaft still rotates easily like this. The pole, support and camshaft operate freely thanks to the linkage. At the same time, this structure prevents damage and wear. The assembly process was not easy. A significant amount of manual work was required. Anyway, I successfully completed the assembly. This side is the channel section. This angle is first gear and rotating it by 165 degrees shifts to second gear. Rotating it another 165 degrees shifts to third gear. This channel is linked to both the camshaft and the main shaft. The channel rotates smoothly thanks to the reduction through the planetary gear. A clicking sound may occasionally occur during channel operation. This sound is caused by the spring's self-alignment action. This sprocket is not used for power transmission. It is simply used to observe changes in speed. If you rotate it like this, you can see the sprocket speed. Currently, it is in first gear. Rotating the channel shifts it to second gear. Rotating the channel 165 degrees makes the sprocket rotate faster. You can hear a slight noise during rotation, right? It is gear noise and the internal ratchet noise. Now let's shift to third gear. You can feel the change in speed, right? This technology was originally developed for electric bicycles. A bicycle is always driven by pedaling, right? In general, gearboxes have limitations when it comes to shifting, especially during hill climbing where high torque is generated. Shifting becomes difficult. That is the problem with gearboxes. That's why I developed a structure that enables free shifting. So this gearbox should allow free shifting, right? As you can see, shifting occurs even while power is being transmitted. For an electric bicycle, you move by pedaling, correct? Gearboxes have limitations when shifting. Do you keep pedaling while climbing uphill? In this situation, shifting may not occur smoothly. You are probably familiar with this. That is the biggest drawback. This technology was developed to solve that problem. As intended, it shifts smoothly even while power is being transmitted. It is operating as intended according to my design. There has never been a gearbox like this before. The channel rotates smoothly under power transmission. There is no binding or impact inside the shaft. As shown earlier, this is possible thanks to the linkage and spring between the support and the camshaft. Because bicycles run at low RPM, under 100, they can shift freely while pedaling. However, in electric vehicles, high motor speeds require precise inverter control. This gearbox is sized for use in real-world applications. Excluding the motor, the gearbox is compact since it has only 3 gears. On the left is the data for the 3-speed transmission, and on the right is the data for the single motor. Both cases use a 10 kilowatt motor. There are 3 key differences. First, the single motor uses a fixed reduction ratio. So the torque is fixed at 180 Newton meters. However, with a transmission, torque is amplified in first gear, so it generates strong torque exceeding 330 Newton meters. That makes steep hill climbing easier, right? Second, there is a difference in efficiency. The single motor is efficient only between 60 and 85 kilometers per hour. Efficiency drops at both low and high speeds. With a transmission, efficiency improves at both low and high speeds. Battery efficiency can differ by about 5 to 10%. Third, there is a difference in top speed. With a single motor, the RPM spikes up to 5,000 at 100 kilometers per hour. Due to the torque relationship, the output reaches its limit at 100 kilometers per hour. With a transmission, the third gear can be utilized. At 125 kilometers per hour, the motor runs at 4,000 RPM with minimal torque loss. At 125, the gear ratio lowers the torque, but the motor's torque itself remains unchanged. In conclusion, there are distinct differences in torque, efficiency, and speed. Even with a 15 kilowatt motor, similar differences can be observed. A 15 kilowatt motor generates about 240 Newton meters of torque. However, it is significantly lower than the 10 kilowatt system with a transmission. The same applies to battery efficiency. Even a larger motor performs poorly in certain efficiency ranges. I will temporarily operate it using a hand drill. I will operate the channel, so please watch how the speed changes. You can see the change in speed, right? At the moment, high torque is not being generated. Anyway, the channel rotation is very smooth. Shifting inside the gear also occurs smoothly. This time, I will rotate the channel slowly. It's the same, the shifting is smooth. The shifting is incredibly smooth. It will be the same even when made with real metal. In fact, it will become even better because it will be more precise. In reality, the channel is driven by a motor, so it operates instantly. Due to precise control through the inverter, it will be very stable.